Hello everyone. Welcome to the first lecture on behavioral modeling. Myself R. Bhagyalakshmi, Assistant Professor, Department of EMC, Government Engineering College, Hassan. In the previous modules, we have studied about gate level modeling and data flow modeling. So, in this module, we are going to study about behavioral modeling. There are several modeling styles available in Verilog. In gate level modeling, we are going to model the logic circuit as an interconnection of the logic gates only, that is AND, OR, XOR, XNOR, and all the available basic gates in Verilog. In data flow modeling, we model the logic circuit as a Boolean function. So, as the complexity of the logic circuit goes on increasing, then it will become difficult to model the logic circuit either by using only logic gates or by using only Boolean functions. So, it is necessary for some higher level modeling to design complex logic circuits. So, behavioral modeling gives us several sequential algorithms which makes it easier to model complex logic circuits. So, let us start with few concepts in behavioral modeling in this lecture. In this lecture, we are going to study about the following concepts. We are going to learn about the significance of structured procedures, always and initial. We are going to study about procedural assignments, about blocking and non-blocking procedural assignments, and a few examples regarding all these concepts. So let us get into the concepts. As we know, behavioral modeling is the highest level of abstraction in Verilog, which will help to model the complex logic circuits very easily for the designer. So, behavioral modeling represents the logic circuit at a very high level of abstraction where the designer describes the behavior of the circuit. So, that's why it is called as behavioral modeling. So, since the design will represent the behavior of the logic circuits, it is called as behavioral model. The behavioral Verilog constructs are very much similar to C language constructs in many ways. So it makes it easy for the designer to learn and apply the concepts in implementing the complex logic circuits by using behavioral model. So let us study in detail about the two structured procedures. The two structured procedures are always and initial. These two statements are the two most basic statements in behavioral modeling because whenever we have to write any behavioral statements in behavioral modeling, so all the statements should always appear within a always construct or a initial construct. So these two structured procedures are very important in Verilog. Each always and initial statement represents a separate activity flow in Verilog. These two structured procedures, always and initial, so they will represent a separate activity flow in Verilog. Each activity flow starts at simulation time 0 for both always and initial constructs. And the statements always and initial cannot be nested. We cannot nest the statements within always and initial. So further, we are going to study about the fundamental difference between these two states. So let us get into the concepts. So let us know in detail about the first structured procedure, that is initial statement. The statements that are written within the initial statement begin their execution at time 0 and they execute only once during a simulation. the statements that are written within the initial block will be executed only once during the simulation. And the multiple initial blocks execute in parallel. So when we have multiple blocks in initial, so all of them will execute in parallel. All the statements will start at time 0 and each of them will finish independently. When we have multiple behavioral statements within initial, then they should be enclosed in between the keywords begin and end. So when we have to write more than a single statement within the initial structured procedure, then it is necessary to enclose them between begin and end keywords. And if there is only one behavioral statement, then we need not enclose it between begin and end. So that is grouping of statements within the keywords begin and end is not necessary if we have a single behavioral statement. So here is the syntax of the initial structured procedure. So it begins with the keyword initial followed by begin, within which we are going to write the behavioral statements if we have more than one, and we are going to end the statements with the keyword end. Whereas if we are going to write a single behavioral statement, then we need not enclose the statements between begin and end. So let us see an example on initial structured procedure. So here in this example, the example begins with the keyword module followed by the name of the module. Here we have declared X, Y, A, B, and M as register. The initial construct begins with the keyword initial, within which we have written a statement yum is equal to 1-bit binary 0. It means that we have initialized the variable yum equal to 1-bit binary 0. And we have the next set of initial statements. So where we have enclosed them between begin and end. So when we have more than single statement, we need to enclose them between begin and end. The first statement is associated with a delay of 5 time units. #5 denotes 5 time units of delay, where we have initialized the variable a equal to 1-bit binary 1, and the second statement is associated with a delay of 25 time units, where b is initialized to 1-bit binary 0. So since we have more than a single statement, we have to enclose them between begin and end. And coming to the third loop, here within initial, we have two more statements written which are enclosed in between begin and end. The first statement is associated with a delay of 10 time units, where the variable x is initialized to 1-bit binary 0, and the second statement is associated with a delay of 25 time units, where y is initialized to 1-bit binary 1. And we have written a finish statement within the initial construct here, which is associated with a delay of 50 time units. So here, if we see the time of execution of each of the statements in this example, here the statement yum is equal to 1-bit binary 0 will be executed at 0th instant of time. Whereas the statement a is equal to 1-bit binary 1, since it is associated with a delay of 5 time units, will be executed at 5 units of time. Then the next statement associated with higher delay is x is equal to 1-bit binary 0 with a delay of 10 time units, and hence This statement will be executed after 10 units of time. The next delay associated here is 25 with 25 time units, that is b is equal to 1 bit binary 0, and hence this statement will be executed after 25 units of time. And also the statement y is equal to 1 bit binary 1 will also be executed after 25 units of time. So whereas the last statement, which is associated with a delay of 50 time units, will be executed after 50 time units. And here the example ends with the keyword end module. So this is how the statements within initial block will be executed with respect to the delay associated with the statements. If no delay is associated with respect to the statements, then all the statements will be executed at 0th instant of time. So let's see about the always behavioral construct. All the behavioral statement inside an always statement constitute an always block. So when we have a set of statements written within the always statement, so they will constitute the always block. The always statement starts at time 0. The execution of always statement will always begin at time 0. And executes the statements in the always block continuously in a looping fashion. So the statements within the always block will be executed in a looping fashion. So whereas in initial block, the statements written within the initial block will be executed only once, whereas the statements in always block are executed in a looping fashion. The statement is used to model a block of activity that is repeated continuously in digital circuits. So, the statements, when we are going to write them within the always block, so we usually write the statements which will model a block of activity, and we need them to be executed repeatedly, that is continuously in a digital circuit. So the best example is an example of clock generator module that needs to toggle every half cycle. So if we write a clock generator module, then we need to enclose it within the always statement. So this is about the always behavioral constructs. So let us see an example on this always behavioral construct. Here in this example, it begins with the keyword module followed by the name of the module. The name of the module is clock generator. Here module is a keyword, and here we have registered clock is declared as a register by using the keyword reg. And here we can see that we have initialized clock is equal to 1 bit binary 0 by using this initial construct. So this statement will be executed only once during the simulation time, so that at the beginning of simulation, clock will be initialized to 1 bit binary 0. So if we do this initialization within the always block, the clock will get initialized again and again to 0. So we write this initialization statement within the initial construct. So coming to the next part, so we have written some statements within the always block. It begins with the keyword always followed by, we have written a statement as 10 clock is equal to not of clock. It means that clock will toggle every 10 time units, so that the clock will change its state from 0 to 1 and 1 to 0 every 10 time units. So that is, it constitutes to complete clock period of 20 time units. And we have written one more statement within initial block here to finish the simulation. So that is, if we want to end the generation of clock after 1000 time units, so then it can be encountered with $finish system directive. So which will end the simulation after 1000 time units. So the statements that are written within the always block are executed in a looping fashion continuously. So whereas the statements written within the initial block will be executed only once. So moving further, we came to know about the syntax of initial and always structured procedures. Now let us see about the assignments inside initial and always. How do we do the procedural assignments of statements within initial and always block? The following values of register, integer, real, and time variables are used to update the values inside initial and always. Here, the value remains unchanged until another procedural update assignment updates it. So here in a procedural assignment, the value will remain unchanged until and unless another procedural assignment will update it. Whereas the same will not happen in case of data flow modeling. So because it is a continuous assignment, very much different from procedural assignment, where the values will get updated immediately. Whereas here, the value remains unchanged until another procedural assignment will update it. So this is the syntax of the procedural assignment, where we have the variable to which something on the right hand side needs to be assigned. So what all can we have on the left hand side of a procedural assignment? So here in this example on the LHS we have taken as L value. L value. So what different values can this one take? So this L value can be a register, an integer, real, or a time variable. And all these can also be chosen as a bit select of all the register, integer, real, or time, or a part select of the above. That is a part of register, part of integer, part of real, or time. So a part select can also be chosen. Whereas it can also be a concatenation of all the above. So coming to the expression part on the right hand side of the procedural assignment. So it is same as we have come to know in data flow modeling. So expression can be of any kind. So here in this assignment, so what will happen if the widths do not match? So if, for example, if the LHS is wider than RHS, then RHS is 0 extended. Whereas if RHS is wider than LHS, then RHS is truncated. So that is the least significant part is kept and the most significant part of the most significant part will be truncated. So this is what will happen if the widths do not match in a procedural assignment. So going on to the next part, let us see the two types of procedural assignments in Verilog. The two types of procedural assignments are blocking assignment and non-blocking assignment. Blocking assignment and non-blocking assignment. So let us know in detail about this blocking assignment statements and non-blocking assignment statements in Verilog. The blocking assignment statements are executed in the order they are specified in a sequential block. So that is, they will be executed just one after the other. So because the blocking assignment statements will be executed in order. So they are specified in the sequential block. So what is the operator used for blocking assignment? The operator used for blocking assignment is single equal to in blocking assignment statements. So let us see an example with respect to this blocking assignment statements. Here in this example, it begins with the keyword initial followed by the statements x equal to 0, y equal to 1 and z equal to 1. All these variables are initialized to 1. So we need to enclose the statements between begin and end. Here we have also initialized count equal to 0. Count is the variable name which is initialized to 0. The next statement we have is register A is assigned with 16-bit binary 0 and register B is assigned with register content in register A. And the next statement is associated with a delay of 15 time units, after which the execution of this statement will take place. So register A of 2 is equal to 1-bit binary 1 will be executed after 15 units of time. And coming to the next statement, which is associated with a delay of 10 time units. So register B, which is a part select, 15 down to 13 is assigned with the concatenation of x, y, z. So here, so since the previous statement will be executed after a delay of 15 time units, then at what duration of time will this statement be executed? So this statement will be executed after 15 plus 10, so that is 25 units of time. So whereas all these statements, first set of statements will be executed at 0th instant of time. Then what about the time at which the last statement count is equal to count plus 1 will be executed? So this statement will be executed after a delay of 15 plus 1, that is 25 units of time. So in blocking assignment, every next statement will be blocked by the execution of the previous statement. So until and unless the previous statement is executed, the next statement cannot execute. So that's why it is called as blocking assignment, since it is going to block the execution of the further statements until and unless the previous statements are executed. So the begin keyword will end with the keyword end here. So in blocking assignment, each next statement will be blocked by the execution of previous statement. So let us get into the next topic. That is non-blocking assignment. So in non-blocking assignments, the next statements are not blocked. So in case of blocking assignment statements, so the next statements will be blocked, whereas the next statements will not be blocked in case of non-blocking assignment statements. So what is the operator used for non-blocking assignment? It is less than or equal to is the operator used for non-blocking assignment in Verilog. So here also we have LHS and RHS similar to what we have come to know in blocking assignment. Only change here is we have a single equal to as a blocking assignment operator, whereas less than or equal to constitutes a non-blocking assignment operator. So this operator is used to specify non-blocking statements. So here in data flow modeling, we have come to know that less than or equal to is a relational operator. So here, when we are going to use it as an assignment operator, then it acts as a non-blocking assignment operator. So whereas if we are going to use it as an expression, so use it as an expression, use it in comparison, so it will still act like a relational operator. So whereas only when we use it in an expression, so it acts like a assignment operator in context of non-blocking assignment statement. Now let us see an example regarding this non-blocking assignment statements. So we have chosen the same example which we had considered for blocking assignment statements, so that we'll clearly understand the execution of statements in blocking assignment and non-blocking assignment. So here in this example also, the example begins with the declaration of x, y, z variables of type register, and the next statement is register 16-bit register. So that is register A and register B are declared as 16-bit register, and count here is declared as a of type integer. So we have used a keyword initial when we have more than one statement. So we need to enclose them between begin and end. So we have some set of statements: x equal to 0, y equal to 1, and z equal to 1. Count is equal to 0. Register A is equal to 16-bit binary 0, and register B is assigned with the content in register A. So here we can see that all these statements will be executed at 0th instant of time. So since they are not associated with any delay, so all of them will be executed at 0th instant of time. So coming to the next statement, which is associated with a delay of 15 time units, and one more statement which is associated with a delay of 10 time units. So since we have used a non-blocking assignment operator here, so this statement register A will be executed after 15 time units, whereas the next statement will be executed after 10 time units. So in the previous case, in case of blocking assignment, so if we would have used a blocking assignment operator, then this statement would have executed at 25 time units, that is 15 plus 10, 25 time units. And what about this last statement, count is equal to count plus 1? This statement will be executed at 0th instant of time itself. So since we have used a non-blocking assignment operator. So whereas in the example for blocking assignment operator, we came to know that this statement count is equal to count plus 1 would have been executed at 25 time units, which will be eventually blocked by the execution of the previous statements. So the example ends with the keyword end here. So this is how the statements within the blocking and non-blocking assignment statements will be executed. So let's continue with the procedural assignments. So as we came to know about the blocking assignment and non-blocking assignment, in case of non-blocking assignment, so when we have concurrent processes, so then there might be some problem in assignment when we have blocking assignment statement. So non-blocking assignment statement. So here we have an example where we'll clearly understand regarding the race condition which can arise while using the non-blocking assignment statements. So here, for example, if we consider, we have used, so here we have written some statements written within the always block using this blocking assignment operator. So always at pause edge of clock, content in variable A is assigned to variable B. Always at pause edge of clock, content in variable B is assigned to a variable A. So here race condition will arise due to blocking assignment statements. So that we need to swap the content in registers A and B, which will not happen properly. So both A and B can retain the old values that will be present in register A and register B. So how can we overcome this problem of race condition? So one solution is to use non-blocking assignments. So in place of using blocking assignment operator, so we can use a non-blocking assignment operator less than or equal to in place of blocking assignment operator. So what happens when we are going to use a non-blocking assignment operator? So during the read operation, so when the content of A and B are read and they will be stored in temporary variables, and during the write operation, so they will be properly assigned to the variables on the left hand side. So that is B and A. So they will be properly written into the variables B and A. So during the write operation, so correct value, proper value will be copied from the temporary variables into the uh, variables mentioned on the left hand side during the write operation. So this is how we can overcome the problem of race condition by using non-blocking assignment statements. So we have one more solution for this race condition. So let us see it with an example. So the solution 2 is, so as I told in the previous example, here we can initially copy the values in registers A and B into the temporary variables temp A and temp B. And then, so we have explicitly mentioned temporary variable A and temporary variable B to copy the values from the register, from the variable A and variable B. So later on, we can transfer the contents from the temporary variable onto the variable on the LHS to which we want to assign the data. So in this way, we can overcome the problem of race condition, which will result in wrong assignment of data to the variables, or which will not result in proper assignment. So these are the two solutions to the race condition that may arise using blocking assignment statements. So here, for concurrent data transfers, so which will result in race condition. So we came to know that. So when we have concurrent data transfers, so when we are going to use blocking assignment statement, so it will give rise to race condition. So this problem can be avoided by using non-blocking assignments. So wherever concurrent data transfers are there. So wherever we have concurrent data transfers, we can use non-blocking assignments. So typical application of non-blocking assignments is in pipeline modeling. But we do have a disadvantage of uh, this allotment to a temporary variable on the right hand side. So the disadvantage is that it leads to lower simulation performance and higher memory usage in the simulator. So apart from the advantages that it will help to overcome the race condition, still they do have a disadvantage of lower simulation performance and higher memory usage in the simulator. So now let us briefly view the questions, what you can expect from the topics what we have uh, discussed in this lecture. Explain the blocking assignment statements and non-blocking assignment statements with relevant examples. Explain structured procedure statements in Verilog. So that is, the two structured procedures are always and initial. Explain procedural assignment statements. So differentiate between blocking and non-blocking assignments. So we can write the differences uh, between the blocking and non-blocking assignment statements. Explain race condition and give solutions for the same. So these are the questions which you can expect from the topics what we have discussed in this lecture. So now let us see a few MCQs, what you can expect from these topics from this lecture. So first question is less than or equal to is used in as a blocking assignment operator, non-blocking assignment operator, both or none. So as we came to know, less than or equal to is used as a non-blocking assignment operator. So this is the correct answer. Let us get into the next question. Which are the two structured procedures? First one is initial and always, and second one is sequential and non-sequential. So initial and always are the two structured procedures as we have studied in this lecture. And the third question is the statements within initial structured procedure are executed how many times during simulation? Whether they are executed 0 times, whether they are executed once or infinite number of times. So as we know, the statements within initial construct are executed only once during simulation. Only once during simulation. So whereas the statements within always are executed in a looping fashion. So this one is the correct answer. So let us get into the next question. How are the statements within always executed? Whether they are executed in a looping fashion or non-looping fashion. So the statements within always are executed in a looping fashion. So this is the correct answer. Coming to the next question. The value remains unchanged until another procedural assignment updates it. So whether the statement is true or false. In case of procedural assignment, obviously it is true. Whereas it is not the same in continuous assignment. So this is the right answer. The value remains unchanged until another procedural assignment updates it. So in case of procedural assignment. So coming to the next question, in the syntax of procedural assignment, L value equal to expression. So what all values this variable on the left hand side can take? So whether they can take only register, integer, real time type variables, only a bit select of the all the above, that is register, integer, real and time, only part select of the above, or a concatenation of any of the above. So L value can take any of these. So that is, it can take a concatenation of any of the above. So this is the correct answer. So the last next question is race condition due to blocking assignment can be overcome using non-blocking assignment, temporary variables, both of the above. So since we can overcome the race condition by using non-blocking assignment, non-blocking assignment operator, and also a temporary variables. So both the above is the correct answer for this question. So these are the few MCQs what we discussed with respect to this lecture. And we do have one more. Equal to is used in which kind of assignment? Whether it is a blocking assignment operator, non-blocking assignment operator, for both blocking and non-blocking, or none. So equal to is used as a blocking assignment operator, whereas less than equal to is the non-blocking assignment operator. So these are the few MCQs regarding this lecture. Hope you have followed the concepts properly. So we shall end this lecture. Let's summarize what we have discussed in this lecture. So we have uh, discussed about a behavioral description which expresses a digital circuit in terms of algorithms it will implement. So we came to know that the behavioral description will express the digital circuit in terms of algorithm it implements. A behavioral description does not necessarily include the hardware implementation details. It includes only the behavior of the circuit. Behavioral modeling is used in initial stages of the design process, not during the later stages, to evaluate the various design related trade-offs. And behavioral modeling is very similar to C programming in many ways. Hence, it is very easy to understand the concepts of behavioral modeling. Structured procedures, initial and always, which form the basis of behavioral modeling. All the behavioral statements in behavioral modeling can appear inside initial and always blocks. And we came to know that an initial block executes only once, whereas always block executes continuously until the simulation time ends. Coming to procedural assignment, procedural assignments are used in behavioral modeling to assign values to register variables. So we use them to assign values to register variables. Blocking assignments must complete before the succeeding statements can execute. So at first, the blocking assignment statements will be executed. Non-blocking assignments, non-blocking assignments, schedule assignments to be executed after the uh, processing of the succeeding statement. So these were the concepts what we discussed in this lecture. So this was the summary regarding this lecture, and thank you for patient listening till the end of the lecture. And this is our team, and these are the references with which we have prepared this presentation. Hope you have understood the topics well. Thank you.